Good morning. Today we're going to work on page 5 and 6 in your packet on isomers and how to name organic compounds. So let's get started. Okay, so isomers are compounds that have the same molecular formula, but they have a different structural formula. I'm just going to write structure because this line is small. They have the same number of atoms, but they have a different shape. Okay, don't confuse isomers with isotopes, which we talked about in Unit 3. They begin with the same 3 letters, so they're often confused. Isotopes are the same atomic number, but a different atomic mass, meaning they have the same number of protons, but a different number of neutrons. So that's a little review for you. Okay, so what we're going to do on this page is, first thing I'd like you to do is draw a straight chain of pentane. So you should be able to easily do this by now. And if you can't, I would go back and watch the video from the first day. Okay, so pentane, so think about the prefix. Pent has 5 carbons, and ANE means single bonds because it's an alkane. All right, so I'm going to draw 5 carbons in a row, and then I need to add in my H's. So one thing that when we're doing isomers, sometimes we just look at carbons because we're being lazy, but we really need to look at our hydrogens as well. So remember that these dashes mean hydrogen. I'm not going to write them all in. So we have C5H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. C5H12. Okay, so that means when I draw my 2 isomers, my formula needs to be C5H12, but it cannot be this same picture. So basically what you're going to do is kind of like move carbons around. Things you can't do, if you bend up, I should have brought my model kit back, but if you bend the last carbon, let's say you put it up, I'm going to get an eraser and just erase this. Let's say you bent your last carbon and you put it up here. That doesn't really change the structure at all because it's still 5 carbons in a row. So the trick I usually tell people is see if you can trace the number of carbons without lifting up your pencil, and you want to have a different number. So I can do 5 in a row without lifting my pencil, meaning that if I can do 5 in a row in any other configuration, like 1, 2, 3, 4, 5, they're the same thing, okay? Even though they look different on your paper, they're actually 3-dimensionally the same, okay? All right, so you could push pause and try to give that a shot. I'm gonna just draw it right now. So what I think the easiest thing to do is to remove the last carbon. I'm gonna put this back in its original spot. Right here. Okay, so I'm going to take off this last carbon and I'm going to put it somewhere different. But remember, I just told you can't bend the end. So that means I'm going to try to pop it in the middle. Okay, so 1, 2, 3, 4. I can't bend the end, meaning I can't put it here and I can't put it here because there are 2 ends. So I'm going to try to put it on either one of these. So I'm going to put it here. And then I'm going to add my H's in to make sure that I have the correct number. Okay, so 1, 2, 3, 4, 5 carbons, 3, 6, 7, 8, 9, 10, 11, 12, 12 H's. So that's correct. And if I trace the line, I can only do 4 in a row. Okay, so the next thing I'm going to tell you is that you can't, if you put this carbon right here in that position instead, that is also the same shape. And we're gonna discuss why in a minute. So I'm gonna try to draw one with 3 in a row instead. So 1, 2, 3. Okay, so remember I can't put extra carbons on the ends because that just bends it, and that's the same thing. So I'm gonna pop them in the center. Right here, right here. And now I'm gonna add my H's in. One, two, three. Okay, so there's C5H12 again. Okay, so this is how you figure out if you actually just drew the same shape. You're going to name them. So on the bottom of your page, it says that you're going to have like a 3-part naming system. You're going to have a number, you're going to have a branch name, and you're going to have a parent chain. I usually work backwards because it's easier to teach that way, I think. Okay, so I'm going to begin going over this, and it's going to be super weird at first. So what you want to do is you want to trace the longest chain with your pencil without lifting it up, just like we were talking about up here. So right here, 1, 2, 3, 4. So I have 4 carbons, all single bonds. So 4 is bute, and single bonds are ane. Okay, so I like to draw that line in. And then I like to circle the substituent, which is just means you have a branch. So I like to circle the branches. So branches, you take the number of carbons. So this is 1 carbon. So 1 carbon equals meth. And branches get named with a YL. So that's a methyl. So it's going to be methyl butane. And then the last part is you need a number. So this is actually the first thing. Okay, so basically what you want to do now is look at your parent chain, and you're going to start counting your carbons on the side closest to the branch. So this side is closest to this branch. Do we agree? Okay, so I'm going to label it 1, 2, 3, 4. And then the number describes where the branch is coming from. So this is 2-methyl butane. 2-methyl butane. Okay, so like 3 minutes ago, I just told you you couldn't draw this picture. I'm leaving the C's off just for, or the H's off just for simplicity. You couldn't draw this picture because it's just the same as this one. It's actually just flip-flopped. But you can check that you didn't draw something that's the same by naming it. So you do the parent chain first, 4 in a row, which is butane. You name the branch. The branch has 1 carbon, so which is meth, add a YL. So methyl butane. And then this is the key. You start counting on the side closest to the branch. So now this side is closest to the branch. So 1, 2, 3, 4. So the name is 2-methyl butane again. So if you end up with the same name, they are the same compound. Okay, so now let's name this crazy thing. So do the same thing. So you want to find your parent chain. So do this, the longest chain of carbons without lifting your pencil. It's right here. 1, 2, 3. Okay, 3. Marvin eats peanut butter. P. It's propane. Okay, propane. Okay, so now I have a group here and a group here. So oftentimes when you have 2 groups, sometimes people say it's ethyl. It's not, because these are separate branches. So you have a 1 carbon branch, so this is methyl. You have another carbon branch, so this is methyl. So I could write methyl propane, or I feel like it saves time just to write dimethyl propane, meaning 2 methyl groups. Okay, and then the last thing we need to do is add the numbers. So it doesn't matter what side we start on. 1, 2, 3. Okay, and then this one is a little bit weird because you need to list the 2 twice because it's off the carbon. It's off carbon 2 both times. Okay, so it's 2,2-dimethylpropane. Okay, so all right, we're in good shape. On the next page, we're going to draw some pictures. So definitely you should be able to draw the straight chains. Okay, let me flip over there. Okay, so this is the page we're working on. So take a minute and draw your straight chains. I'll draw them too. I'm gonna push pause and do that. So maybe if I can get this out of the way. Sorry, I'm having some trouble here. There we go. Okay, so I'm gonna pause recording. Okay, I'm back. So I drew the straight chains. You definitely should be able to do that by now. So I looked at the prefix. Hex is 6. Ane means single bond, so I drew that. Hept is 7. Ane is single bonds. Oct is 8. Ane is single bonds. So normally, like if we were in class, I would have you just practice drawing them however you want and naming them from there. But since I can't see what you're doing, I'm just gonna have you name these either in this column, name them, in this column, draw them from the name. Okay. So if you want, you can push pause. Otherwise, I'll just go through the naming right now. Okay. So in the first one, first thing you do is trace your longest parent change. There we go. So we have 1, 2, 3, 4, 5. So now my last name is pentane. Okay, and then this is my branch. My branch has 1 carbon, so this is a methyl. Okay, and now the last part is count the number of carbons. So since this branch is in the center, I can start counting on either side. So I'll just go forward. 1, 2, 3. So this is 3 methylpentane. All right, next one. Longest chain. 1, 2, 3, 4, 5, 6. Hexane. A branch with 1 carbon is a methyl. And now start counting on the side closest. So it's closest to this side. So it's 1, 2. So this is 2 methylhexane. Okay, and then the last one, 1, 2, 3, 4, 5, 6, 7. They don't always have to be the bottom line, but that's often how you'll see them for like basic chem stuff. So 7 is heptane. We have a methyl group right here, methyl. And then what side is the branch closest to? It's closest to the left. 1, 2, 3. So this is 3 methylheptane. Okay. So push pause and try to do the last column. You're going to draw it. So remember, the last name tells you your parent chain. This tells you your group. You can see that they're all methyls. So it's just a 1 carbon chain, 1 carbon branch. And then the 2 tells you what carbon to put it on. All right, so take a break, do that, and then come back and get the answers. All right, so I'm gonna talk through it. No, it's been a while, but 1, 2, 3, 4, 5 for pentane. Methyl is a group of 1, and it's off the 2nd carbon. So I could put it here, right? That's the 2nd carbon, or I could put it on this side. I'm gonna put it on this side because all these counted left to right. So remember, when you count your branches, you count on the side closest to the branch. So there we go. Add in your H's. Sorry, this one's a little messed up. And you're all set. Okay, 3, oh, this should not say 3-methylpentane. This should say 3-methylhexane. Because if I did 3-methylpentane, I would only have 6 carbons. Okay, so let's do that instead. So 1, 2, 3, 4, 5, 6. That's my hexane. Methyl is a branch with 1, and it's off the 3rd. So it could even be pointed downward. Add your H's. Okay, perfect. Okay, and then the last one, hexane is 6. 1, 2, 3, 4, 5, 6. Dimethyl means you have 2 methyl groups. So you have a branch here, and you have a branch in another spot. Okay, so the first branch comes off the 2nd carbon. So I can start counting in either direction. I'm going to put it here. Okay, so that's my first methyl group. So this is 2-methylhexane, which would only have 7 carbons, and that would be an isomer of heptane. So to make it an isomer of octane, I'm going to put in another methyl group off the 4. So since you already started counting in the left to right direction, 1, 2, 3, 4. The other one's going to go right here. So it can point up, it can point down, whichever you prefer. And then add in your H's, and then we're done for the day. There we go. Okay, so tomorrow we're just going to practice drawing and naming, and then you'll have a little assignment over the weekend. Okay, perfect. So let's stop here for today, and I'll talk to you tomorrow.